Hey 7X, today we are actually going to really get into using the Pythagorean theorem. And the Pythagorean theorem is used to find the missing side lengths of a triangle. So sometimes we're going to have to find a leg of the triangle, other times we're going to have to find the hypotenuse of a triangle. I broke it down into a couple of different days. So today we're going to start with just solving for the leg of a right triangle. Okay, so let us remember from yesterday that the Pythagorean theorem is a squared plus b squared equals c squared. Okay, a and b have to be your legs and c has to be your hypotenuse. Okay, your legs are the two sides of the triangle that make that right angle, and the hypotenuse is the longest side of the triangle that is always the side opposite of the right angle. Okay, so also, please remember that we are going to have to square numbers and we are going to have to take the square root of a number. So squaring a number is multiplying the number by itself, and finding the square root of a number is identifying the number that we can multiply by itself to get the number inside the radical or inside the square root. Okay, so let's do some examples here. Here I gave you a right triangle. Okay, I gave you the length of two sides of the triangle. You're missing a side length down here. That's what we use the Pythagorean theorem to figure out. We want to use the Pythagorean theorem to figure out the length of this side of the triangle. But now we need to be able to identify if we're solving for a leg or if we're solving for a hypotenuse. Okay, I did tell you that today we're only going to be solving for legs. But again, I know this is a leg because I was given one leg over here and I was also given the hypotenuse. Okay, so we're solving for a leg here. So I need to use the Pythagorean theorem again, which is a squared plus b squared equals c squared. I have the steps written out for you over here in these yellow text boxes, so please use them to your advantage. Okay, so what we're going to do is we're going to plug in the information that we have given in this picture into our Pythagorean theorem. All right, so we know a squared plus b squared are going to represent the square of our two legs of the triangle. But we don't have both legs. We only have one. We're figuring out the other one. So I'm going to leave a squared exactly how it is. I'm going to call the first leg that I'm solving for a squared. I don't know what a is yet. I don't know what that other leg is yet. But I know what my second leg is equal to. It's equal to 9. So for b, I'm going to plug in 9. Okay, I also know what my C is. My C is my hypotenuse. I gave you the length of the hypotenuse. The hypotenuse is equal to 15. So I'm going to plug in 15 for C. Okay, that's step 1. Step 2 is to now square the leg and square the hypotenuse. Again, notice how I just brought down the a squared the a squared because I don't know what a is yet. Okay, so I just bring it down. Now I have to square 9. 9 squared is 81. Remember, when we're squaring a number, we're taking that base, that number, the larger number, and multiplying it by itself. We're not doing 9 times 2. You're doing 9 times 9. Okay, then I got to square my hypotenuse, which is 15 squared, which equals 225. Now, guys, look, we have a two-step equation here. We have a squared plus 81 is equal to 100 or is equal to 225. So our step 3 is to subtract the square off the leg, which is just 9 squared, which is 81. Subtract 81 from both sides of your equation. Okay? All right, it says subtract the square off the leg from the square off the hypotenuse. Guys, the reason why it just says square off is because 81 is the square of 9 and 225 is the square of 15. Again, if I drew the square off of both sides, that's what the area would be. Okay, so I bring down the a squared. 225 minus 81 gives us 144. Okay, so now what I have, ignore the square root symbols for a second, but now what I have is a squared is equal to 144. I didn't solve this equation yet because this variable a is not all by itself. Right now it has the square, okay? Remember from yesterday and the day before, the opposite of squaring a number is to take the square root. Squaring a number and the square root are inverse operations of each other. So in order to get rid of that square, I am going to take the square root of both sides. So I'm going to take the square root of a squared. The square root of a squared is simply a, because a times a is going to be equal to a squared. Remember from our unit on exponents. So the square root and the square cancel each other out, so I'm just left with a. Now I have to take the square root of 144. Well, the square root of 144 is 12. So we get a is equal to 12. Okay, so that tells me that the length of this leg of the triangle is equal to 12. All right, let's do another example. Here we have another triangle. Again, we are solving for this leg here. I gave you one leg and I gave you the hypotenuse. It's our job to figure out what the other leg is. So I'm going to call the other leg right now a. So I just bring down the a squared. Now, instead of typing in b, I'm going to type in what my other leg is equal to. My other leg is equal to 10, so I'm going to plug in 10. Then I'm going to plug in what my hypotenuse is equal to. My hypotenuse is equal to 16, so I'm going to plug in 16. Okay? Now, step 2, I got to square this leg and I got to square the hypotenuse. I bring down the a squared because I'm not doing anything with that yet. So 10 squared is equal to 100, and 16 squared is equal to 256. Okay, so I squared both my leg and my hypotenuse. Now I'm going to subtract the 100 from both sides of the equation. Okay, minus 100, minus 100. Okay, I'm bringing down the a squared. 256 minus 100 is 156. Okay, now I need to get this a all by itself. Right now it's not all by itself. It has a square, so in order to get rid of a square, we take the square root. Remember though, what we do to one side of the equation, we must do to the other. So if I'm taking the square root of this side of the equation, I must also take the square root of this side of the equation. So the square root of a squared is simply a, and the square root of 156 is 12. So again, we get a is equal to 12, which tells me that the length of this leg of the triangle is equal to 12. Okay, guys, we're basically just plugging in numbers and then simplifying and solving an equation. Okay, we'll do another one. Here we have another right triangle. Again, we are solving for this bottom leg here. I gave you one leg and I gave you the hypotenuse. Okay, so first step is to plug in the leg in and then plug in the hypotenuse. Again, I'm going to call the missing leg A, so I'm not going to plug in anything for A yet. But I know what B is. B is my second leg, which is equal to 4. Okay, and my hypotenuse is equal to 8. All right, now we have to square the leg and the hypotenuse. Again, bringing down the a squared. 4 squared is equal to 16, and 8 squared is equal to 64. Now we're going to subtract 16 from both sides of the equation. Bring down the a squared. 64 minus 16 is 48. Now I'm going to take the square root of both sides. So the square root of a squared is a, and now we're going to take the square root of 48. Notice how in the step 4 text box, guys, I wrote round your answer to the nearest whole number. Sometimes it's going to work out where the number underneath the square root isn't a perfect square, which means there does not exist a number that I can multiply by itself to get 48. So we're going to get a decimal, which is fine. You guys are going to have to use a calculator for this. Just simply round it to the nearest whole number. So if I take the square root of 48, I get like 6.928, so on and so forth. Really? I'm just looking at 6.9. I'm rounding that to the nearest whole number. So a is equal to 7. Okay, so the length of this leg of the triangle is going to be equal to 7, rounded, which is fine. All right, do one more. All right, another right triangle. I give you a hypotenuse, which is equal to 20, and a leg that is equal to 16. We are solving for the other missing leg. So for B, I'm going to plug in my leg, which is 16, guys. We got to be careful that we're plugging in our legs and our hypotenuse in the correct order. And our hypotenuse is equal to 20. Okay, now I bring down that a squared because I don't know what a is equal to just yet. I'm now going to square 16. 16 squared is equal to 256, and 20 squared is equal to 400. Okay, now I'm going to subtract 256 on both sides of the equation. Bring down the a squared. The 256s are going to cancel each other out, and 400 minus 256 gives us 144. Okay, Now I have a squared is equal to 144. Again, we want to get that a squared all by itself. So the opposite of squaring a number is taking the square root. So I'm going to take the square root of both sides of the equation. So the square root of a squared is a, and the square root of 144 is 12. So we get a is equal to 12, which tells me that the length of this leg of the triangle is equal to 12. Okay, all right, we'll do this last one. All right, another right triangle. Again, this triangle is just positioned a little bit differently than what we're used to seeing, but again, I gave you a leg and I gave you the hypotenuse here. A way that you can identify that this side length of 3 is the hypotenuse is if you draw an arrow from that right angle. Okay, so I know my leg, which we're going to call b, is equal to 2, and my hypotenuse is 3. Okay, now I'm going to square this. 2 squared is equal to 4, and 3 squared is equal to 9. I'm going to subtract 9 on both sides. I'm sorry, I'm going to subtract 4 on both sides of my equation. Bring down the a squared. Your 4 is going to cancel. 9 minus 4 is equal to 5. Okay, now I got to solve for a, so I need to get a all by itself. So I'm going to be taking the square root on both sides of the equation. Square root of a squared is a. Square root of 5. 5 is not a perfect square, which means we're not going to get a whole number here. So again, we want to round our answer to the nearest whole number. So when we take the square root of 5, we get 2.2, so on. So to round that to the nearest whole number, it's just equal to 2. So we get a is equal to 2. Okay? All right, ladies and gents, you are now going to complete the solving for the leg of a right triangle assignment. If you have any questions, as always, please reach out.